and welcome to another edition of Let's Talk. I have two special guests with me that I'm sure are going to be very enlightening. So we are going to talk about sharding, and these two guests are going to explain it to us, and they also have done some extensive work regarding sharding, which you will find out about. So my two guests are Yaoqi and Xinshu. So welcome, both of you. And so why don't we do this? Why don't we start with Yaoqi, and why don't you explain kind of your background, how you got involved with blockchains, and just kind of who you are. So can you start there? Can we do that?
Okay, great. Yeah, thanks for Christian's introduction, and hello everyone. I'm Yaoqi, the blockchain architect in Zilliqa, and right now I'm in charge of the development team in Zilliqa. So I got my PhD in National University of Singapore, and during my PhD period, I've been doing research on consensus protocol, security and privacy on PP networks. And so basically, we have developed some protocols to enhance the privacy of P2P systems using new crypto primitive like ORAN, and also some new hardware features like Intel SGX. And after that, together with my colleagues, Xinshu and Amrich, and also our team members, we sort of collaborated and designed our new consensus protocol and blockchain protocol called Zilliqa, which can precise high throughput and also using the sharding technology. And yeah, so we started in the summer of this year for this completely new project called Zilliqa. And yeah, that's for my part. And,
okay, so you went to the university in Singapore, and is your team based at the university there?
Hi, Christian, Xinshu here.
Yes. Yeah. Okay. Go ahead. Good.
Yeah, the team is now based in Singapore, and our office is at a corner of this university campus. This is a very nicely designed building. It's like the incubator for the university for startups from the university. Of course, because we are growing, so the team is a little bigger now. We'll probably move out to another office very soon.
Oh, okay, but you're affiliated with the university, but you're not all employed with the university. You weren't all professors there. I'm just trying to get a sense of.
So you can call this Zilliqa as a spin-off, from this university.
Okay, but it started at the university level when you guys are doing research. Is that correct?
The original idea of using sharding to make public blockchains very scalable stem from the research in a research lab led by Professor Pradeep Saxena. And after that, a company was founded named Anchen. Pradeep Saxena is also a co-founder of this company. So the company was founded to sort of further develop this technology into a commercial product. So that was a permission blockchain for 1 or 2 years. And then we started this project Zilliqa, which is really to take the technology to the next step as a public blockchain. And then we officially kicked off this project in June this year. So that's sort of a very brief history of how this came about.
And why don't we find out a little bit more about you? So how did you initially get started, Xinshu, in the blockchain space and being interested in?
Yeah, very interestingly, I worked with Pradeep Saxena very closely during my PhD life. At the time, my research topic was mainly on cybersecurity for web browsers and web applications. Then, I moved out to work for another company working on the software security for larger scale systems like smart grid or transportation systems and Internet of Things. And then, as I mentioned, Pradeep Saxena founded this company, Anchen, with the other two gentlemen in 2015. And then they told me they started working on blockchain. So I was very excited. I already had some personal interest in a study on blockchain at that time. But then really it's like after I joined this company, Anquan, I started to work on blockchain full-time, leading the development of this scalable blockchain for permission settings. So that's when I started working on it really.
Yeah, I have a background in computer security also, and I was interested in cryptography. And so, yeah, the blockchain technology is a natural fit for people that are interested in cryptography and in security, right? Trying to make the world decentralized. So I can certainly understand why you would move into blockchain research.
Yeah, exactly. The blockchain gave me an impression that this is going to be a very impactful technology. So it goes beyond the technology itself, but it will bring many opportunities for new businesses, for example.
Yes, a lot of potential. All right, and so you guys have been working on a solution to the scalability problem. So the my understanding is blockchains provide a trustless platform because one of the ways that they provide it is with redundancy. Every node, every computer on the network has to have a copy of the entire blockchain, run all of the smart contracts. And if you want performance conflicts or it could conflict with the desire for decentralization, right? And so the dream is to have decentralization, a trustless platform, but also have performance. Did I say it correctly?
Yeah, I think blockchain is really about having resilience, and one way to have resilience is to have redundancy, at the very high level, and really the scalability is to try to maintain the redundancy or resilience at the same time, but also achieve much better performance.
Right. And so, did you guys explore other potential scaling solutions before you focused on sharding, or how did you come to choose that one?
I think there are several directions in terms of scalability for the blockchain, and we are really mainly talking about the public blockchain at this moment, because previously I worked on the private blockchain or permission blockchain. There, it was a completely different story. You could have many optimizations or make more assumptions about the environment, because it's a permission blockchain. You have some control there. You can have also other security countermeasures. For example, you can limit who can join the network. That will be very helpful in terms of maintaining the security of the blockchain itself. But when we really talk about a public blockchain, you are talking about an open environment where every node can potentially be malicious or be compromised. That's really a different story. So here you have solutions that move some of the transactions off the blockchain, such as the Lightning Network or this Reader Network, and you have new ideas based on proof of stake. That will solve the issue that you have to pay lots of electricity, power, and cost to get blocks mined. So then there's a sharding. So I see these are several important directions. For off-chain payment channels, I think they are very practical. They are a very important and promising direction to pursue, especially for payment. But that's not the main problem we are trying to solve, because we want to solve the scalability problem on the blockchain itself. That means we want to solve the scalability of the platform itself, so that all these general applications today running on the blockchain can benefit from there. But for off-chain channels, I think their main application is for payment.
Yeah, so like the Lightning Network, that improves the performance for payments, but we need sharding to improve for general smart contracts. Is that what you're saying?
Yeah, that's the high-level idea, and that's why we are working on this scalability problem for the blockchain itself.
And proof of stake may decrease the energy costs, the energy requirements, but it's not going to make transactions necessarily faster.
I think it's both. It will, of course, decrease the energy cost, and at the same time, it will also improve the throughput. But I think Yaoqi can share a little bit more on our sort of thoughts and comments on proof of stake and why we decided to go with alternative routes to that.
Okay, sure. Yaoqi, you wanna mention?
Yeah, I think right now you may know some well-known proof of stake solutions like Ethereum Classic and EOS, and also some ongoing projects like this Tendermint, also the Definity. For these projects, they basically use proof of stake based on how much stake you hold, and then your voting right is proportional to the amount of your stake.
Right.
So in this way, usually they run the proof of stake protocol and build up this consortium group. Basically, usually like less than 100 nodes to run the consensus protocol and to produce the blocks. For example, for EOS, right? They have these 21 so-called block producers, and then these 21 block producers basically run the consensus protocol and generate these new blocks for the whole network. So there are two issues. Basically, the first issue is that until now we haven't seen any proof of stake protocol is probably secure in this sort of asynchronous network. And so I just give you a simple example. So for proof of stake protocol, right? If for one round you do the security analysis, maybe some nodes follow the protocol and then they can gain profits at the maximum amount. However, for several rounds or multiple rounds running of the consensus protocol, sometimes some nodes can behave maliciously and disrupt the execution of the protocol. But after the analysis of several rounds, these nodes may get more profit than they directly follow the protocol. So right now we are still waiting, waiting for the academia and also these industry people to do more security analysis on that. So since for the all proof of stake protocol, they are based on this crypto economics assumption. So it's quite different from the current assumption of Bitcoin, Ethereum. That is Byzantine assumption. So basically, we still think the POS is a nascent idea. And definitely, after our mainnet launches, we may spend more time to exploring this open problem on proof of stake and the security proof of proof of stake. The second issue so basically after these solutions use proof of stake to elect new nodes as the representatives of the whole network, and these nodes can run sort of the variants of BFT protocol to reach the consensus and generate new blocks. However, you can check their web papers or their technical details in their GitHub. So basically, usually this consortium group is quite small. US has 21 nodes, and for Casper, they propose like 100 nodes. So then you may see there is a centralization problem, right? So the whole network actually sort of controlled by this a small group of nodes, and they run the consensus protocol representing the whole network. Right. And so these nodes may easily get attacked by DOS attacks or the other attacks. And in that way, even these nodes may be elected by the proof of stake or some other similar protocols, but you can see it's still not that decentralized.
I see.
So this is also this hot topic when people debate about this proof of stake plus BFT with this Nakamoto consensus like Bitcoin or Ethereum. Some people really like it because, to be honest, proof of stake plus BFT, such solutions actually can scale the, basically can achieve high throughput for the blockchain. However, the other group of people really don't like it because it's not properly secure and it's sort of centralized and it's not that democratic.
Right. No, that's a very good synopsis. So you think proof of stake may help with scalability, but you have concerns about security and centralization. So
yes,
and so you're maybe taking a wait and see approach to see how it matures and if they can address your concerns. I think that's a good synopsis. Why don't we move to what you're known for, your sharding work? And so I'm not an expert on sharding, and I know a lot of the audience is not an expert. So my understanding is that we split the blockchain into lots of pieces, and we process the work for those pieces in parallel. And so that's the general way that we achieve better performance. Is that correct?
I think it's right. At a very high level, people can just say this is a typical divide and conquer process. You have a bunch of nodes in the network. So instead of asking them to do the same thing at the same time, you divide them into smaller groups with each group processing a subset of transactions in parallel. And eventually you sort of combine them, and that's the final thing. Then you have your block for the next round.
Right.
So that's the high level idea.
Yes.
The thing is, there are many subtle details, although they're subtle, but they're very critical.
Yes.
That need to be sort of answered. So number one is, what do you really divide, right? So you divide the nodes. So what does it mean? So these nodes still contain all the states of the global network, or the nodes will only contain partial information with respect to this particular group or shard. And another question is, how do you divide the nodes? You can just appoint some super nodes as master nodes. They can just say, okay, you go here and you go there, right? But that's not ideal. It's very centralized. So how do you do this in a very secure and decentralized manner? And the number three is, after you divide, how do you really conquer? And after you conquer, how do you aggregate the results? And after you aggregate the results, what do you do with this? So there are all these subtle details that make our sharding scheme quite different, I would say, quite different from other sharding schemes out there or being proposed by different groups of people. So what we call our sharding scheme is something called network sharding or transaction sharding. So that's directly different from the other popular idea, which is called state sharding. So in state sharding, when a node is allocated to one shard, this node will only have information, within that shard. So it doesn't know, what's going on with another shard. So there are many pros and cons here. The pros are very obvious. You are really dividing the network into different parts, and then, by not worrying about anything happening outside my group, this saves, number one, storage cost. And number two, the bandwidth required to sort of propagate information when you say you need to share information across. The cons are, number one, because you don't know anything going on outside your shard. Sometimes when you process a particular transaction that involves, let's say, an account belonging to another shard, you need to talk to another shard. So this kind of communication across different shards may become a performance bottleneck, unless we have very smart ways to do that. So this is number one.
Yes. Oh, yeah. That's an interesting point. So if I imagine we separate the blockchain into pieces and have different nodes control different accounts, let's say like on Ethereum or Ethereum Classic, and if the transaction only involves accounts within the shard, then it happens quickly. But the trick, of course, the subtlety is when it involves accounts in other shards, and you have to communicate with another shard to get the account information. And then the concern you're saying is that instead of being a performance increase, that could be a bottleneck, and so you don't want that. Is that correct?
Yeah, that's what I see as one of the major challenges in making a good scheme for state sharding. And number two issue we do not have a perfect solution as yet is when a node is sharded into a group using state sharding. It's not easy to move that node around. You see, it's not as straightforward as say next round you just move that node to another shard because it doesn't know what has happened in the other shard. So this has some implications because if you cannot move nodes around between different shards, the nodes are sort of stuck there, and they are always there. Attackers can just sort of focus their attacking power to a particular shard because the attackers know exactly who are the nodes in that shard, and the number of nodes there in the shard is significantly smaller than the number of nodes in the entire network.
Right.
So,
so when you were okay, if I could just clarify, when you were talking about moving nodes, are you talking about, like, for example, if I disconnect my computer from the network and then I decide next week to connect again, then if I go on a new shard, that's what you're talking about? Is that what you mean by moving a node to a different shard?
that's one scenario. There's another scenario which means I as a node I'm always online, but if there's a state sharding, so very likely I'll be belonging to one shard all the time, and that to me is also not ideal in terms of security.
Okay, so we need a way that people can be moved to nodes could be moved to different shards, but then that creates other problems, and you're saying that there's still no simple solution then to that. Yeah. Okay, all right.
So, Christian, I can give you some simple examples for in terms to Xinshu's question.
Sure.
So the thing so you think about this network, right? It's open network. So nodes frequently join and leave, online and offline.
Right.
So due to the security considerations, basically you want to reshuffle the whole network frequently, right? Periodically. Yes. It's like every 2 hours or every 10 hours or something. And after that, if you reshuffle the network, so some nodes in shard A, they may move to shard B and shard C. So if we keep working on this state sharding, since every node within one shard, it only has its own shard data or state. So it has to exchange with other nodes in the other shard it's like a state exchange, right?
Right.
So in this way, it's not that simple. So basically, you have to exchange the data and to make sure everyone is synchronized on the data side. And this is one thing. The another thing that is so-called airplane and hotel problem is like in different shards. Suppose there is a transaction in shard A, so A transfer money to B, and there is another transaction happening in shard B. Basically, B transfer money to A. So you can see there's some correlation between these two transactions. And to make it the transaction atomic, so you have to allow different shards to communicate with each other, right? So this also introduces some complexity to this state sharding scheme. To be honest, I think state sharding is quite promising, but right now it still has a lot of problems and issues to be resolved. So that's why maybe I can share with you more about our sharding scheme. And so for us, right?
Right.
The sharding is quite different from state sharding.
Okay.
So here I may introduce several new concepts, like we call our sharding. Our sharding consists of network sharding,
Mhm.
transaction sharding, and also computational sharding.
Okay.
So the thing that you think about, there is a network with like 6,000 nodes in the network,
Yeah.
and we divide these 6,000 nodes into 10 shards. So every
Okay.
shard has 600 nodes.
Right.
And so this is so-called network sharding. So basically, we divide nodes into different shards. After that, within each shard, we do these. Within each shard, they process different transactions. So it's like every user or wallet can submit a transaction to the network, and based on the sender's address, we will divide this transaction into different shards. This is what we call transaction sharding.
Mm-hmm.
So after that, within each shard, it has its own set of transaction, right? Then they
Mm-hmm.
perform a new consensus protocol, which is a variant of BFT, and to reach consensus of the same set of valid transactions. Of course, all the nodes within the shard will validate this transaction, whether it's correct or not. And then they reach consensus of the same set of transactions.
Okay.
So in this way, you can see in parallel, the different shards all run consensus protocols, the efficient BFT protocols, and reach consensus of different set of transactions. After that, we sort of through this directory directory service committee, which another shard with 600 nodes. This shard basically will aggregate the results, all the agreed transactions, and then broadcast to the whole network. In this way, every node within each shard, they will have the big picture of the whole network, which means the current state of the whole network.
Okay.
So right now we don't.
Oh, sorry. Now let me just make sure I'm following you. So did you say that the mining is not sharded, or in other words, so we don't have separate miners for every shard? The miners will mine all the shards at the same time. Is that correct? Did I understand that?
So the manners, you mean the nodes in the network, right?
Like
so
the consensus algorithm is yeah. Does every shard have its own? You talked about every shard having its own consensus algorithm, and so it has miners, right? Like in Bitcoin. Yes. And so, do the miners, are they assigned to one shard, and they only mine for their specific shard? Is that
so? It's partial correct. So the thing that our nodes in the network, or our miners in the network, at the beginning they will do a round of proof of work. And based on the result of the proof of work, they will be divided into different shards.
Okay.
So it's like we don't really do proof of work to reach consensus.
Okay.
We just like the proof of work is just like entrance tickets.
Okay.
Once you do some proof of work, you join our network, and you will be divided into different shards.
Okay.
And within each shard, you will, together with all the nodes within this shard, run the consensus protocol. That is what we call computational sharding. Yeah.
Oh, so in order to have your effective sharding solution, you were forced to modify the consensus protocol. You're okay. So you can't just use the standard Bitcoin proof of work or the Ethereum proof of work protocol, you're saying. Okay.
Yeah, so
is that right?
we don't use the Nakamoto consensus. It's our consensus protocol is also a variant of PBFT.
Okay. Okay. And also it sounded like I heard you say that there was hierarchy of nodes. They're not all the same. And there was a set of nodes that broadcast to other nodes. Can you talk more about that? Clarify that?
So yeah, definitely. So basically in our protocol, we have these normal shards, and also there is a directory service shard. Mm-hmm. So for normal shards, they basically run consensus protocol to agree on the same set of transactions for each shard. And for the directory service protocol, directory service shard, they will run consensus to agree on the same set of transactions which already agreed within each shard. So it's
Okay.
like for aggregation.
Okay. Okay. So there's a consensus within a shard, and then there's another consensus for the aggregation. So it's like two levels.
Yes.
Okay. Okay. And okay, great. And I think I understand kind of the overall idea. And so let's see, what else was I going to ask? Oh, so what is the current state? You said that you admitted that there was still some subtleties to be worked out. So how close is this to being ready to be used in like every blockchain system, for example, like Ethereum or Ethereum Classic?
I think, these subtle questions, we at Zilliqa already have, answers to them. But, that's really our answers. And in theory and in experiments, we have shown like our answers basically work. It's a practical thing to do. Even with all these known to be secure, very conservative approaches, such as POW and BFT, we can reach very high throughput. We get a very good scalability. But on the other hand, how other people may answer these questions, really is a choice to them. Because in Ethereum, for example, they are advocating using proof of stake, and their Casper scalability proposal is largely related to their proof of stake scheme. So I think to me that's also a very interesting direction to explore. Like, I think there's no simple answer to all these subtle problems.
Okay, so with their choice of Casper, you're saying that it wouldn't be possible to run your sharding algorithm because it requires a proof of work consensus algorithm. Is that correct?
I think it's also a little difficult to say whether it's possible or not, right? Because it's just software. So in the extreme case, you can adopt another software's algorithm, right? It's just like they already have sort of a direction to go ahead with. So it's just a little difficult in practice to completely adopt Zilliqa's idea.
Okay.
But this is for now. It doesn't mean like 2 years or 3 years from now, different blockchains cannot learn from each other, right?
Right.
We're pretty much open and very keen to collaborate with other blockchains, including Ethereum's sharding idea, just to see what is the best to do for all these hard problems in different blockchains.
Okay. Yeah. One reason I was really excited to talk to you guys is when I read about the Ethereum Foundation's work on sharding, it always sounds like, they're working on it. It's not very mature. But then when I read your work, it sounded like, you guys were way ahead or really advanced. You're really confident in your work and your solution. And so I wondered, how come the Ethereum Foundation isn't, as advanced as you guys? That was just something that went through my head. Maybe they should be working with you guys or partnering with you guys. Since
we'll be happy to. It's just like for us, there's only one priority, which is making a new very scalable blockchain. But for Ethereum, this is already a very very grand, very healthy, very lively ecosystem. So there are just too many things they can work on, I think.
Okay. But you're not, you haven't been in contact with them, or you're both of your research programs are independent.
We are in close discussion with them.
Okay.
Of course, it's in private conversation, so I cannot disclose the exact details. But we are in discussion.
Okay, but all right, and also, so you mentioned that the security, you have a security background like me. So how did you analyze the security of your algorithm and try to imagine attacks to prevent them? Can you kind of talk about that kind of security of your system?
I think one good thing we have is we are sort of leveraging on several very sort of classical approaches, right? So like for the practical presenting fault tolerance algorithm, which our consensus protocol is based on, this is a well-known thing that has been fully analyzed. We do not change the basic steps in this protocol. What we only did was optimizing how could you actually implement it, how could you for example improve the efficiency when you do digital signatures. So that's why the security is sort of guaranteed and analyzed based on that. And for the sharding algorithm, this original idea all started from Loy and Predict's research paper on Elastico. So that's also a research paper that has been fully analyzed and peer reviewed in top conferences.
So you're building on the work of Elastico, or you're learning from their research. Is that kind of what you're saying?
Yes, you're right.
Okay. And all right. So describe also how, can you go more into detail how transactions are assigned to shards? I know we went over that a little quickly, but can you kind of elaborate on that again?
So for transaction, right? So basically nodes and manners or wallets, they can all send the transaction to our network via these lookup nodes, and which are also distributed in our network. And the transaction is assigned to different shards basically based on the sender's address.
Okay.
So based on your address, it will be distributed to different shards. So yeah.
Okay, so the different shards control different subsets of the address space.
Yeah, sort of.
Okay. And then how also the concern that people have is of the double spending. So can you kind of go a little also more detail of how your algorithm would prevent double spending? I know you talked about the broadcast to aggregate. Go ahead.
Yes. So basically, as I just mentioned, right? So we don't do state sharding, and we have this aggregation and also the broadcasting of all the transaction and state to every node. So basically, every node, even the node is just within one shard, it has the current state of the whole network.
Okay.
So within every shard, all the nodes can do the validation of these basic checks for each transaction, like whether the sender has enough balance, or whether the sender is belonging to this shard. The sender's address is belonging to this shard or not. Yeah, all these essential checks, security checks, will be done within each shard by every node. Okay. And so in this way, actually, we can prevent the double spending attacks. And finally, every shard will propose these valid transactions and submit to the whole network.
Okay. Just to repeat, so the broadcast, the state of the entire system of all the accounts, that's what you're broadcasting, among other things. Is that right?
So if you look at our white papers, so there are also some detailed, there are also some very interesting details. Actually, we have this transaction block, and in the block header, we have this state root hash. So basically, record the current state of the whole network, similar to Ethereum. So basically, to record every account's balance and just do a macro tree on top of it and generate the root hash and store in the transaction block header. After that, I just mentioned this directory service community, right? The directory service community will broadcast this transaction block to the whole network. We call final block, and then every node can basically, based on the final block and fetch different transaction bodies from different shards. In this way, they can get synchronization and keep the latest state of the whole network.
Okay. All right. Now, so this is all great work. Can you say something about your future plans? What's future? What's down the road for Zilliqa and your research? You want to comment on that?
So, Zilliqa's mission is really to create a scalable blockchain platform so that people can build high throughput apps running on that. Zilliqa does not want to reproduce an ecosystem like what Ethereum already has, which is very good. Our mission is really to provide a platform that enables people almost immediately, let's say from next year onwards, to build these high throughput apps that cannot be supported by today's blockchains.
Okay.
So for the short term, we plan to release our source code by the end of December. Of course, there's still lots of things to do just to make our functionality a little bit more ready to open up our code. And we are trying to get a public testnet ready as well, so that we can invite some of these miners to voluntarily contribute their mining power to start running a public testnet, so people can see how it works, people can feedback, and would definitely run into issues so that we can address. And this is one line of work. Another line of work we are currently doing is the design of our smart contract. I think today we didn't get much opportunity to talk about that. It's still in the early stage. We are going to release the design document for our smart contract. It's going to be a formal language. It's going to be running very efficiently on our platform, but at the same time, it can avoid many of these security issues and bugs that people have been seeing on today's smart contract platform. And because that's a formal language, really it's very difficult to write a programming. So we have a front end as well that is going to have a syntax very similar to Solidity. So we'll convert that, Solidity-like syntax into that formal language when it's actually being executed. So for that, we need a little bit more time. For example, we will probably have a first implementation of our smart contract language by the end of Q1 2018. And we'll do more testing. We hope we can have our mainnet go live by Q2 or end of Q2 2018. Okay. So that's roughly our timeline for the next few months.
Okay, you said something I have to commend you on. That's really wonderful. So when I read, like I was mentioning, when I read the Ethereum Foundation's papers, research on sharding, it's a lot of theory, right? But there's no real tangible thing that you could analyze, or no software that, right? But so you guys are going to have a test net. You guys are going to have a network that people could write smart contracts for. They could use sharding, right? And so it's not just a lot of theory, but there's going to be software that they could see that's running. So if they can see that sharding works. And so I think that's a big step that's really going to be helpful, right? To not instead of just reading a bunch of theoretical papers, to have a network. So that I think that's that's great. And also you have a token generation event, or ICO. Did I understand that correctly, coming up?
Yes. So our plan is to let people come on board doing some paperwork in terms of KYC or AML in December, and then we will actually launch our token generation event, the public one, in early Jan. And at this stage, we're actually very close to the end of an early contribution round. So people have already shown their very strong support. Actually, we're actually overwhelmed by their support for our early contribution round. So I think we are all set. We'll go ahead and deliver this platform as we promised.
Okay, great. Now, if I think sharding is an important contribution to the scaling problem. If people have listened to our interview and they're interested in sharding, they're interested in your work, what sources of information, what do you recommend that they start? Where should they start to investigate?
I think, if you go to our website, zilliqa.com, we have two documents there. Number one is a technical white paper that details exactly what we did. Of course, it requires a little bit of background in computer science, But if you just want to have the high level idea of what we're doing, there's another paper called position paper, which is written in a more layman term.
Okay.
So of course, we have our Slack and Telegram channels. If you have technical questions, feel free to join our Slack channel. It's also listed on our website. And we also have our blog. There's a link on our first web page, front page as well. So there's a series blog articles detailing the technology we developed in Zilliqa.
Okay.
And join our discussion on Slack. So that there are already lots of very lively, deep and sometimes heated discussions there. So you are welcome to join us.
All right, wonderful. So there you have it. We have not just theory, we have white papers, we have a network, test network, soon to be a live public network. So yes, that's all great news. I think we've given a good introduction, and not just to sharding, but to your work and some of the concerns. Yaoqi, have I covered everything? Or was there something else that you wanted to add that I didn't mention?
Yeah, I think that's good, really good.
Okay, so all right, and Xinshu, was there anything else that I missed or that you wanted to mention about your work?
I think it's all good.
Okay, all right, great. So thank you for giving us an introduction, and thank you for your great work. And yes, best of luck, and I'll be following your work carefully. So
thank you very much. It was nice chatting about it.
Yeah, thanks, Christian, and thanks everyone listening.
All right, thank you. Bye-bye.